Prove that the exterior angle of a triangle is equal to the sum of the interior opposite angles. It's basically the proof of Theorem 6. Okay, so we call it Theorem 6. Okay, now, okay lads, so with these proofs, there's only certain things you need to learn. First of all, you need to know what you're targeting. So we're going to make a triangle with an exterior angle on the outside. Okay, now essentially what the only information I've learned off by heart is that this yellow angle plus blue angle is 180. The green and the green angle plus the pink angle plus the blue angle is 180. Therefore, the yellow angle must equal the green angle plus the pink angle. Okay, that's all I have to say. I have to do this using formal maths language. Okay, so that's the plan. So you don't have to learn all the letters off by heart or all the numbers off by heart. Here's a quicker, more efficient way of doing it. That's all I have learned off of this question. Okay, so all I'm going to do is I'm going to write down exactly what I said earlier, right? So we're going to use a formal language here, okay? So we'll just label our triangle ABC, or any letters you want. Hell, I'm going to name it PQR, okay? Just to be awkward. I'll call this one angle 1, angle 2, angle 3, and angle 4. Okay, so what we're given? We're given a triangle PQR, so that's a Q, PQR, well, my Q's tend to look like R's a lot. Okay, PQR with interior angles, with interior angles 1, 2, and 3. Labeled 1, 2, and 3, and an exterior angle labeled 4. Now, what am I looking to do? I'm looking to prove that angle 4 equals angle 1 plus angle 2. So what am I trying to prove? Angle 4 equals angle 1 plus angle 2. What's the proof? Well, angle 1 plus angle 2 plus angle 3 equals 180 degrees. You give a reason. 3 angles in a triangle add to 180. Okay, next thing after that, we're going to say angle 3 plus angle 4 is 180 as well. And the reason behind that is, what's the reason? It's a straight angle. Now, next thing we know is that this means that, therefore it follows that angle 1 plus angle 2 plus angle 3 equals angle 3 plus angle 4. And then what we can say there is that angle 3's cancel. So therefore angle 1 plus angle 2 equals angle 4. And that's what we're asked to prove. That's one down. So just to let you know, this first one was 2019 question 12. I would have already done it for you. It's 2019 question 12. The next one is 2017 question 9C, as it turns out, right? So the first thing we're going to do is we're going to draw ourselves a parallelogram. Okay, so you can just choose any generic looking parallelogram. Now, the thing what I have to do here is I have to prove that this red side equals this red side here, and these two angles here also equal each other, okay? Now, what I'm going to really try to do here, guys, is I'm going to try and split the parallelogram into two triangles, and then try and prove that those two triangles are congruent. That's what I'm looking to do. That's the only part I have learned off. Okay, got to make up my own letters. P, Q, R, S. What am I given? I'm given a parallelogram PQRS. Okay, what am I looking to prove? Well, I'm looking to prove that PS is the same length as QR because they're opposite sides. And then I'm also hoping to get PQ is the same length as SR because they're opposite sides. Now, what I'm going to do regards my construction, well, I need to draw a diagonal. Doesn't matter which diagonal. I could draw a diagonal P to R if I wanted and do it that way, or I could draw a diagonal S to Q and do it that way, or sorry, S to Q and do it that way. So draw a triangle, so draw a line, draw a diagonal line from S to Q. Okay, draw a diagonal line from S to Q. Okay, next I'm going to try and prove that these two triangles are congruent, right? That's my plan here. Really need to make sure that these guys are congruent. We're just going to transfer this further down the page. Okay, I could do with that. Okay. Now, on your triangle, you might want to label your angles. I'm going to mix this up a little bit. I'm going to call that, sorry, which ones do we want here? I can call this angle 3, angle 4. I can call this angle 1 and angle 2. Just mixing it up just to make sure I'm not learning this off by heart. I'm doing it because I know the actual procedure. Now, the procedure is two sets of alternate angles. Okay, so I can say here is angle 2 plus angle 3. Sorry, angle 2 is equal to angle 1 because it's an alternate angle. Okay, now please remember I'm trying to prove that this triangle here, the green triangle, is congruent to the blue triangle. Doesn't matter what the names are, that's basically what I'm trying to do here, okay? Next thing I can do is I can also say angle 3 equals angle 4 because it's also an alternate angle. Okay, so angle 3 equals angle 4, alternate angle. Okay, now what I've actually proved there, and this is actually, you could be asked for this proof. In this proof, we're actually asked for opposite sides are equal in length. I'm also going to do opposite angles are equal in length as well. Okay, now at this stage, you could say that angle 2 plus angle 3 is the same as angle 4 plus angle 1. So therefore angle PSR is the same thing as the angle PQR. Okay, and now you've proved that this angle here, opposite angles are the same. That's if you want to do that. That's no big deal. Okay, now what we can do next then is we can, we're not asked for that anyway, so I'm just going to leave that be. Okay. And so therefore, if angle 1 equals angle 2 and angle 3 equals angle 4, this would mean angle 5 has to equal angle 6. And why would angle 5 equal angle 6? It's the third angle. They're both the third angle and the other two angles are the same. Okay. So now we know that once again, and that's proven the other opposite angles are the same. Angle P, that would mean angle SPQ would equal angle SRQ. And that's your two opposite angles proved, no bother. Okay. Now, we got to prove that these two triangles are congruent. So, they have a common side, don't they? What's the common side? Common side is SQ. So, we're going to target the triangle SPQ and SQR. So, I always write down triangle SPQ and triangle SQR. I better write in some of these numbers here. This is 5. This is 6. This is 3. This is 4. This is 1. Oh, sorry, that's 2. And this one is 1. Okay, just because I need to see what I'm writing, okay? Now, first thing we're going to do is we're going to say that SQ equals SQ because it's a common side. It's a common side. All right, so that's a side. Now we can say angle 3 equals angle 4. So angle 3 belongs in this one here. And angle 4 belongs in that one there. We already said that earlier, didn't we? We said that's an alternate angle. So I didn't necessarily need to write this twice. And then finally, angle 3 equals angle 4. And then we got angle 2 equals angle 1. And once again, that's alternate. Now, what we're going to see here, guys, is that we have an SAS equation here. Sorry, ASA. Angle, side, angle, triangles SPQ and SQR are congruent. By angle, side, angle. Otherwise known as ASA. Therefore, 3 dots. This means PS is the same length as QR. PS equals QR because they're corresponding sides. Corresponding sides means they're in between the same size angles on both triangles. And then we can say that SR equals PQ. And we're done. Okay, so in that one I actually proved the opposite angles in the parallelogram are equal. I also proved that the opposite sides in the parallelogram are equal. Okay, okay guys. So the diagram we're going to start off with is a triangle. Remember, you can use any letters you want. So PQR for my one. No big deal, I don't have to have all this learned off, okay? I'm going to pick some angles. I'm going to call it angle 1, angle 2, angle 3. I don't have that learned off in any order either. Okay, so what am I given? A triangle PQR with angles 1, 2, and 3. Okay. What do I want to prove? I want to prove that all 3 angles, angle 1 plus angle 2 plus angle 3, they all equal 180 degrees. And what do I want to do next? Or what do I do in the construction? Well, construct a line that goes through Q that's parallel to PR. You got to make sure, because you're going to use alternate angles, you got to make sure that that line you construct up top, I mean, call it any letter you want, call it a line L. Okay, so what I'm going to say is construct a line L through, and which point did it actually go through? It went through Q. That is parallel to PR. Okay, so see, I don't have any of this learned off. I'm just looking up at the diagram, okay? Now I need to label my 2 new angles. So label angle, what's it, angle 4 and angle 5. Label angle 4 and 5 in this then label angles, angle 4 and 5. Okay, so the first thing we're going to say is that angle 2 equals angle 4. They're, what's that word, alternate. And angle 1 equals angle 5, once again alternate. So we're just going to drag the two of these down into our proof. So angle 2 equals angle 4 and angle 1 equals angle 5. These are alternates. Okay. The top, then we look at the top angle, which is a straight angle. So angle 3 plus angle 4 plus angle 5 has to equal 180 degrees. Reason being, it's a straight angle. So that's a very easy proof as well. Whoop, don't want to do that. Alternate angles, the second one's alternate angles. And then you can say that's a straight angle. Therefore, what can we say now? Therefore, we can say that angle 1, because angle 3 plus angle 4 is the same as angle 2, and angle 5 is the same as angle 1. Therefore, angle 3 plus angle 2 plus angle 1 is equal to 180. And that was what I was asked to prove. Okay, that's another one down. That was 2016 question 6. Okay, or basically Theorem 4, I believe, or Theorem 4. Okay, we're going to see what other theorems we need to do. Alright guys, what we have here is Theorem 19, or the 2014 question 4. So Theorem 19 or 2014 question 4. That's where you will find this one, okay? Now once again, I'm going to mix up some of my letters here, okay? So that's obviously a parallelogram, you don't want that. Okay, so we'll pick a center of a circle and we'll just draw a circle. Once again, seem to be drawing a parallelogram. Okay, so there's my circle. I'm going to label 3 points on the circle in no particular order. P, Q, and R. Okay, and what am I given? And a center O. Okay, a circle of center O and 3 points, and the points P, Q, and R, which are on the circle. Now what am I trying to prove? Well, I'm trying to prove that this angle here so basically what I'm trying to prove, if I was to use color here, I'm trying to prove that this pink angle to the green angle is twice the pink angle. Okay, now you can see I did a bit of construction there, so I need to write in what I need to do. So what I'm going to say is join Q to P. Draw a line joining Q to P. Sorry, my fault. Yeah, I'll take like this out. Draw a line joining Q to P. Another line joining P to R. And draw 2 radiuses, and draw the radius, and draw the radius linking, draw the radii is plural, I suppose. Draw the radii linking Q to O and O to R respectively. Respectively just means in that order. Okay. And then label the angles 1, 2, 3, 4, and 5. Okay. So, oh, I also forgot to link, forgot a big one there, guys. I forgot to link P to O. Remember, it's like the Star Trek sign with a line through the middle, making two congruent triangles. Okay, so we better put that in. So Q to O and P to O. And O to R, respectively. Okay, and one last part, we're going to need our exterior angles. So join a line P that goes through O and extend the line PO to a point, any letter of your choosing, P, Q, or S. We'll call this one S. Okay, so then we can say extend the line, extend the line PO to a point S. Okay, done. Next thing, we're going to have to throw in some angles. No particular order. Angle 1, angle 2, angle 3, angle 4, and I think we're going to need angle 5 and angle 6, so that'd be 4, 5, and 6. Okay, now what am I trying to prove? I'm trying to prove that angle 5 plus angle 6 equals 2 times angle 1 plus angle 3. I'm essentially trying to prove that the angle QOR equals the equals 2 times the angle QPR. Please remember that's an O there, that's QOR. Okay, so how are we going to do this? Well, if I remember correctly, this is basically what I have learned off by heart. Okay, yellow, green equals green because it's an isosceles triangle. Blue equals blue because they are an isosceles triangle. Therefore, yellow being the exterior angle, yellow equals 2 greens. Pink equals 2 blues. Okay, so basically your yellow angle plus your pink angle equals 2 times the green angles plus 2 times the blue angles. Basically yellow plus pink is 2 times green plus blue. All right, but we've got to write that down. Okay, so I'm going to write it to the side of the board here, and then I'll transfer it down in a second in the proof. Okay, so first thing I'm going to say is angle 1 equals angle 3, reason being isosceles triangle. Okay, then I'm going to say angle 2 equals angle 4, reason being isosceles triangle. Next thing I'm going to say is angle 5 equals angle 1 plus angle 3, and angle 6 equals angle 2 plus angle 4. And reason being is exterior angle. Okay, so I'm just going to transfer all this down here now. Don't want that. Isosceles triangle, and 2 of them are exterior angles. Exterior angle and exterior angle. Now, next thing we're going to do that is we are going to remember we said angle 1 equals angle 3, therefore angle 5 must equal, now which angle is actually at the top of my one here? it's actually angle 1 I need to use. So it's 2 times angle 1. Because angle 3 is angle 1, and angle 1 plus angle 1 is 2 times angle 1. Okay. Likewise, angle 6 is equal to, now once again, which one am I going to use? I'm using angle 2 at the top, so it's going to be 2 times angle 2. Okay. Therefore, it leads in that angle 5 plus angle 6 equals 2 times angle 1 plus 2 times angle 2, which is 2 times angle 1 plus angle 2. And that is basically what I was asked to prove. And I'm done. Okay, so that's that one done, guys. Okay, lads, now this is Theorem 14. This is a substantial proof, okay? Now, the way I have this learned off is I basically, once again, I'm going to be jumbling up all my numbers, all right? Because I want a right angle triangle to begin with, okay? So here's my right angle triangle. Now, I think what I like to do with this right angle triangle is that I want to turn it around. I like having that line flat. Now, I don't want it to be perfectly, I don't want it to be isosceles either. I want a different type of right angle triangle. Let's see what options I have here. I'll make my own one. Right, so I'm going to make it like this. Okay, and this is right angle. Oh wait, make that shorter. Okay, then there we go. There's a right angle triangle. Okay. Now, the thing about this is, actually, we want to make this whole thing a lot bigger. There we go. I think this is probably going to be the most difficult part of this. All right. So I'm going to make up 3 letters: P, Q, and R. Okay, what are you given? A triangle PQR. Where where angle PQR is guaranteed 90 degrees. Okay, what am I looking to prove? Well, I'm looking to prove my hypotenuse, which is PR squared. I'm looking to prove that PR squared equals PQ squared plus QR squared. Okay, now I have this learned in the following way, guys. I know we're going to use similar triangles. That's the first thing I know we're going to use. And both times I need to use the hypotenuse of both of the smaller triangles. And also you see me saying hypotenuse squared. They're the only 2 things I have learned off for this, okay? So next thing I'm going to do is going to get Q. I'm going to draw Q perpendicular to a point M. So what did I just do there? Drew a line through Q that's perpendicular to the line PR, which cuts PR at point M. Okay. Next thing I'm going to do So lads, what you're going to have is you're going to use similar triangles, okay? Now I see 3 triangles. I see the very large triangle PQR, which we will have here. P to Q to R. Okay, so that's P. Whoop. That's P, that's Q, that's R. Okay, over here. Then you have the smaller triangle PQM, which is the triangle on the left. PQM. So here's P, QM. Just sort of writing them along the side at the moment, okay? Just keeping them out of the way. I need to straighten that up to be a right angle triangle. And then finally we have a triangle QRM, okay? Now the deal is to try and prove that the left triangle is similar to the right triangle. But the best way to do that is to prove that they're both similar to the largest triangle. Okay, so there's three triangles in that diagram. There's the left triangle, which is the smallest triangle. There's the right triangle, on the triangle on the right hand side, which is QRM. That's the medium sized triangle. And then finally there's the largest triangle, which is the full thing. Geez, not let me take out this segment here. Okay, that's all I wanted. Okay, so I'm going to label them and we're going to start working on how to make these guys similar. Okay. So I'm just going to leave out the proof section for a minute and we're going to continue proof section. I'm just going to get rid of it there and we'll do that later, okay? So what are the three circles I have in mind? I have P, Q, and R. I have P, M, and Q. And then finally I have Q, M, and R. Okay, so I'm still on the construction. Label angles. So let's label our angles. I'm going to call this angle 1, this one angle 2, and the third one angle 3. 1, 2, and 3. Okay. Now, what we can say next is the following. I can label, and I'm going to label some other angles as well. 1, 2, 3. I'm going to label that one 4. This one 5. They're both right angles, 4 and 5. And I'm going to label angle 6. Now I might not necessarily need 6, but we'll go for it anyway. Actually, I don't need 6. Excuse me. We won't need 6. We just have to prove they're similar. So if we prove two angles are the same, we can prove that if two angles are the same, the third angle is automatically the same, so therefore they're similar. Okay, so 1, 2, 3, 4, and 5. Okay. Now, next thing we're going to go for is, let's prove that the small triangle PQM is similar to the large triangle P. I want to prove that PQM is similar to PQR. So let's begin. I would say that angle 1 will equal angle 1 because they have a common angle. And that angle 5 will equal angle 3. So there we go. I can prove they're similar pretty quickly, right? So angle 1 equals angle 1 because it's a common angle. Then I can prove that angle 5 on the small triangle is equal to angle 3 on the large triangle because they're both 90 degrees. And because then you can say that the third angles have to be the same. So therefore, triangle PQM and PQR are similar. Okay. Now, likewise, what you're going to do next is you want to prove that PQR is similar to the right triangle, which is QRM. They have angle 2, they have angle 4, and an unknown angle up top, okay? So what I can say here is that they have a common angle, where 2 will equal angle 2, they're a common angle, and then basically 3 will equal 4. That basically means the triangles QRM and the triangle PQR are similar. So triangle QRM, I'm trying to prove that the triangle, once again, PQR. Okay, Angle 2 equals angle 2. Reason is their common angle. And therefore, angle 4, which is the right angle triangle in that triangle there, must be the same as angle 3 on the large triangle. So that's about 90 degrees. Ergo, triangle QRM and triangle QRM and PQR are similar. Now, if QRM and PQR are similar, but PQM and PQR are similar, this means that triangles QRM and the small triangle, basically you wanted to prove that the left triangle is similar to the right triangle, so PQM and QMR are the same. So PQM. So the first step is proving that the left triangle is similar to the right triangle using similar triangles, where you both prove that the left triangle is similar to the largest triangle and that the right triangle is similar to the largest triangle. The next thing we're going to do is we're going to target the hypotenuse. Okay, we're going to target the hypotenuse of every single triangle we have here. Okay, so that's my plan here. I'm going to bring the two of these guys down here. Okay, so these are the two triangles I've been trying to work with. There we go. Okay, that didn't go as well as I would have liked. Now, here's what we're going to do. So there's your QRM and your MPQ. Okay? So, because we know they're similar to each other, what we can say next is that essentially we know that this yellow, they're about 90. We know that this pink one has to equal 2. And then we know that this one has to equal angle 1. Okay, so we can spell that out. We can say angle. So we know that both these triangles are similar. Okay, so we're going to pick a side. Now remember what I said earlier, the key is using the hypotenuses. Okay, so the key is to use the hypotenuse on each triangle. So the whole point of my question is I want to prove that PR squared equals PQ squared plus QR squared. I need to get PQ on its own. Okay, and we might use that with the large triangle. Okay lads, so what we're going to do here is I'm looking for PQ squared. If you look at the large triangle here, what the whole goal is PQ squared plus QR squared equals PR squared. Okay, that's the whole point of Pythagoras' theorem. That's our target. Okay, so I'm going to target PQ. So I'm going to, first of all, I'm going to find out where my two PQs are. Okay, so my two PQs I have, I'm going to do large over small. The large triangle divided by a smaller triangle every time. Okay, the largest triangle is this one. That's the large. That's a medium triangle, and that's the small triangle. Okay, so we're going to do large over small first. I'm going to pick PQ in the large triangle. Okay, and then I'm going to see PQ is in between the white angle and the yellow angle. In between the white angle and the yellow angle on the small triangle is PM. Okay, and then I'm going to pick PQ on the small triangle. PQ on the small triangle is in between the pink and the white. So that means PQ goes down here. But on the large triangle, what's between the white and the pink is PR. Now when you cross multiply this, what should happen is you'll get PQ multiplied by PQ is PQ squared, and then PM, it's going to be PM multiplied by PR. Okay. Next thing I'm going to use is the large over the medium triangle. Okay. So what we're going to do here, guys, is we have to find out what QR is. So let's use QR on the large triangle. So it's going to be QR, which is in between the yellow and the pink. And in between the yellow and the pink on the medium triangle would be MR. Like this. Then we're going to pick QR on the small triangle or the medium triangle. Now we're doing large divided by medium. So QR on the medium triangle is in between pink and white. So that'd be QR on the bottom. And then what we're going to do next is we're going to use the same one on the large triangle. What's in between the white and the pink on the large one? Well, that's PR. Like so. Once again, cross multiply and we get QR squared equals PR times MR. Okay, now here's the magic part. You're going to link both of them in at the same time. Okay, so here's what you're going to do. You're going to link them both at the same time. So we're going to say that QR squared plus PQ squared is equal to PR times MR plus PM times PR. Now imagine this, guys. Imagine this was XY plus ZX. That PR is X and the other two. You can factorize it out. You can basically say X into Y plus Z. So that's my intention here. My intention is to factorize out the PR. Okay, so we're getting PR, big bracket times, it's basically the length of MR plus the length of PM. Okay, and that equals QR squared plus PQ squared. Now, if you look back up the very top, what is MR plus PM? There's MR. And there's PM. And when you add them together, you get PR. So essentially this has become PR by PR. And what you've proven there is that you've proven Pythagoras' theorem. QR squared plus PQ squared equals PR squared. Now guys, please remember, you're not going to learn all that off by heart. So how are you actually going to learn this in a couple of quick steps, all right? What you're going to have is you're going to have three triangles. Three triangles. Draw hypotenuse low. All right, so what we mean by that is we're going to have our lines like this. You're going to draw the hypotenuse low. Everybody cool with that? Next thing you're going to do is you're going to draw a line going straight down. What you want to prove is that the smallest triangle, which is the blue triangle, you want to prove that it's the same, it's similar to the large triangle that you started off with. And likewise, you want to prove that the medium triangle is also similar to the large triangle. Okay, that's your first step. So you want to prove large is similar to medium and small triangles. Okay, whatever you call them, whatever letters, whatever concoctions you call them. Okay, next thing, when you're done with that, what you need to make sure is you target the hypotenuse of both triangles. So this is your target. Your targets are going to be this one here and this green line here. That's why I targeted both of them in these questions here. Okay, you can see I was always targeting the hypotenuse. See the way I targeted PQ. I targeted PQ, and that's PQ here, and then I targeted PQ on the large triangle as well. So I targeted on the small and the large. And likewise, I targeted QR. QR is the hypotenuse of the medium triangle. So I'm targeting the hypotenuses of the small and the medium triangle, and that's why I'm using them both in both parts of the question. That's how I know to target them like that. Okay, so that's it. Draw 3 triangles, draw your hypotenuse. Prove the large is similar to the medium, and prove that the large triangle is similar to the medium and the small triangles. Next thing you do then is target hypotenuses. Target hypotenuses on both triangles and cross multiply. The cross multiply bit, guys, is where you do see here to here. That's the cross multiplication bit, okay? And then you need to factorize, and then factorize. The factorized part is this part here, where we factorized it out and turned it into Pythagoras' theorem, right? So that's pretty much what I have scaffolded learned. I don't have it all learned off by heart. I'd have it all pretty much like this in my head.